Today, the plan is to introduce functional programming and later on introduce test-driven development with jest and vue-test-utils. I guess it's best if I quickly show the new homework exercise. Is that right? Shall I do that? I guess it's probably a good idea. So I just pushed a new homework exercise, which you can find. Go to our homework repository and you navigate to the exercises folder, and you can navigate to exercise 2. And this is it. So it's now on the homework repository. I was asked in the forum if I could sneak preview the next homework exercise, which we do in the homework draft repository. Feel free to watch. Well, you should of course watch this repository, but you are also free to watch the homework draft repository. But maybe you will get some notifications when we, for example, force push changes to this repository. All right, so in this homework, you're going to do test-driven development, and you have to set up your own continuous integration, continuous delivery pipeline. And I also want you to check out component-driven development with Storybook. And you are welcome to extend the existing code that you have from exercise number 1. Actually, you have to. Then there was confusion about the reviews in the last exercise. Together with Yuri, we came up with the following method or procedure. If you send us a review before the 2nd week, that is until the 4th of November for this exercise, we will give you like an intermediate review, all right? I think that's a good idea for educational purposes, and you can improve your existing exercises. And from then on, if you give us a review in the 2nd week, that will be your final submission, and then we'll give you a review after the deadline, including grading. Does that make sense? Maybe you want to add something?
Yeah, just to clarify. So whenever you do a pull request, so for instance, if you do a pull request after the 4th of November, then we see it more or less as you are done and you could consider yourself done, and then you will get your grade, and that's it. But if you do it prior to the 4th of November, then you will still have the chance to improve your homework and get some additional points. The thing is that we just can't allow a constant back and forth between you, your team, and us. So that's why we said, okay, until the 4th of November, if you do a pull request until then we will review that in time, so you have a chance to improve. But afterwards, it's basically the final grade.
Yeah. So when Yuri says pull request, what Yuri means is requesting a review on a pull request. You can always create pull requests. You can create as many pull requests as you wish. Just when you submit when you request a review from us, that's your submission. Does that make sense? Shall I stop the sharing and have a quick look into the chat? Or Yuri, can you see the chat and give me some feedback if people are fine with it?
Steven is typing. But looks good until now.
Yeah, and last lecture we talked about online learner communities and how Git commit IDs are formed. This will be this has some relevance for the next exercise. I decided against putting that into the current, in the next homework. So I said, okay, fair enough. To have a connection to the lecture, to the last lecture, let's put this as an optional objective. So the idea is you can easily record your pair programs. You do pair programs already. So why not just record them and collect that knowledge for later as part of your documentation. And if you want to be really cool, you can also publish that video. And Yeah, in another homework exercise, maybe we will ask you to actually do that as part of the objective, and then you would send us the link to the video. If you don't want to publish it, you would send it as, or you would mark it as unlisted. Another optional objective is you should like make use of the knowledge that you gained in last lecture and git commit amend your commits. And if you do that for commits that you already pushed to your pull request, then you know this will change, or this will create a new commit ID. And then you have to get around the problem that Git tells you, well, there's a new commit online because it's different. And then you have to force push. So we didn't really cover it in deep. So I said, well, let's make this optional. But you're very welcome to check out these objectives. So that's it for introducing the new homework, I would say.
So there's a question whether there are bonus exercises giving extra points.
No.
So
No.
we have 10 points here on this exercise 2, as well on the exercise 1. And if you do the optional things, you don't get extra points. But as you get 60% for the, I think it was 60% for the exercises in total anyway, you could basically say every 5th point is a bonus point.
Exactly. And you gain good karma if you do the optional objective, of course, you know? I mean, you want to learn something, right? So it's not about those points. This is a formality. This is our way of having some measure, some objective, transparent measure for you to get, like, to construct this irrelevant grade at the end of the lecture. But most importantly is what you learn, okay?
Yeah, he said he's asking for a friend.
Oh, yeah, right, cool. All right. Then, having said that, I would say let's continue on with the slides, and then I can also open public chat now. So one reason why the lecture from last week was took so long to publish is that I was like sharing my screen while opening the public chat on the left side, and then we have to cut it out. And so now I can see the public chat, and yeah. Feel free to ask questions, feel free to unmute yourself. Let's continue on. Functional programming. I mean, you saw that a little bit in last exercise, where I asked you should use functional programming paradigms. And many of these functional programming paradigms found their way into modern programming languages. Unfortunately, from my experience, people who start to learn programming with languages like C or Java don't feel like used to this concept. But in fact, many programming languages have like traces of functional programming in the language, including, for example, Ruby, Python, Scala, Golang, Rust, and so on. So it's actually a piece of knowledge that you can universally apply to all your software development. And yeah, so what is functional programming actually? What's the definition of a functional program? A functional program is that the program is constructed by applying and composing functions. So functional programming is all about that. It's basically the definition. Might be a nice exam question, for example. And one of the most important things here to understand is that you have pure functions and impure functions. And you can see the definition of a pure function on the left part of the slide. You have two properties. One of them is you don't have side effects. And the other one is that the return value of the function is the same for the same set of arguments that you put in as input to the function, all right? And what is a side effect? You can see that on the right side. If you, for example, mutate some state, then this would be a side effect. For example, a couple of you mutated the argument that you passed into a function in last homework, and I said, there you have a side effect. It is better, or it is good practice to always try to avoid those side effects, and in question, then you just create a new object, you create a new array, and return that instead of mutating the argument that you received from the caller. Yes. Does that make sense for now? I was told by another fellow student that I should not ask you everything okay, but instead ask you the same question inverted, because it's easier to say yes instead of no. So now I'm asking you, are you confused? Yes or no? Ha! More people are hitting the yes button. Fair enough. So if you're confused, it's, for example, interesting for me to understand, okay, what can I add here as an input for you? Please really ask your questions in the chat. Right now, I don't know how to explain this a little bit better. I mean, 6 people have said, I am confused right now. I can see no one typing here. I'm a little bit nervous now to just continue on with 6 people here.
Maybe just
having
specify
difficulties.
what the confusion is about. Is it about the pure functions? Is it about functional programming, or what is it about?
One person is typing, so I'm waiting. And maybe give another example of how to avoid non-functional programming. I mean, like avoiding pure functions, I guess is the question. One example I said is like you mutate an argument that you put into the function. It's just something that is tempting, right? Instead of creating a new object, you just mutate the existing one. Another one is that you mutate a state which is outside of the function. Another one might be writing to the console. It's also a side effect. And regarding the return values, the same for same arguments. We will come to that later. We will ask a quiz question where you can really see the difference on particular examples. Okay, and maybe I will just continue on explaining referential transparency. That's a property that pure functions have. So if you have a pure function, those functions have this particular property, which means that you can, instead of running or executing this function to get a result, you can also replace the entire function with the corresponding value. So think of a functional program like a tree. You have a function, which may be called other functions, which in turn call even more other functions. This will construct something like a tree. And it kind of reflects, or it is like the same principle, which is behind updating, for example, the virtual DOM tree in Vue.js, where only those parts of the tree are updated when the properties are changing. In homework 1, you have seen that when the properties of components are changing, then the component re-renders in the virtual DOM. And Vue.js is performant because it is able to update only those parts which are in fact changing. Have the same idea in mind when you think of a functional programming with this tree-like structure of calls. If you have, or like if you know this is a pure function and the arguments to the functions didn't change, then you can, for example, set up a caching system where you don't execute the function and just take the value from the cache. And pure functions, pure programming languages like Haskell, for example, leverage this property to have to improve performance. Yeah, does that make sense? Do you get the idea? Should I have shown you a diagram maybe here of a tree-like structure, or can you imagine? Okay, can you not imagine what I was talking about? All right, so someone is writing. That was the most confusing question ever. Okay, maybe. I mean, I want to just get some feedback while I'm talking, right? Especially when I'm introducing like theoretical concepts like this. Go for triple next time. Yeah. Yeah. Okay. So referential transparency, one benefit of referential transparency can be to set up caching and yeah, has benefits for performance. Double negations, yeah. Okay, maybe that was not such a good idea. I mean, the idea of the student was it is easier to say yes instead of no because so few people are saying I don't understand or can you please slow down? Yeah. All right. Maybe just go on with the next slides. So here are the quiz questions. We have a couple of examples for impure functions in JavaScript. And I will go one by one now, and you tell me which of the properties that you saw on the first slide, no side effects, or return value is not the same for the same arguments, is not satisfied here. So I'm creating a custom poll, and I will ask for console log. What do you think? What is violated here? Is it side effects or return value same for same arguments for console log? It seems to be quite difficult. I don't receive so many answers to the poll like immediately. Yeah, I can see that quiz question. You have to need more time to think about the answer. All right, shall I publish? This is interesting. This is really interesting. It's okay, you cannot see the answers. I should maybe use an abbreviation then. So the first answer was side effect, and the second one is same argument for same return value for same input. So why not just try it out? So I'm going to create, I'm going to share my screen and create maybe an example here, example.js, and say console log something, return value. Want to see, actually I can also use my browser, right? The browser shows is an interactive console. A read evaluate print loop, which I have here. So when I say console log something, then the return value is undefined. So regardless of what I put in here, the return value is always undefined. So the return value doesn't change, no matter what I put into as arguments. No, this one, developer Mozilla is always the best reference. So does it have return value parameters? Return, no. Maybe there's something missing or I'm not getting everything. But anyways, the return value is always undefined. So the correct answer here is it's side effects. It's side effects which is violated here. Because writing to the terminal is a side effect. There is no return. No, there is a return value. The return value is undefined. A function always has a return value. Okay, so someone doesn't really understand the problem. Okay, can you help me? How can I explain this a little bit better? What's the problem here? So the quiz question is, which of the two properties are violated? These are all impure functions, so at least one of the properties are violated here. And the problem is, or the question is, which property is violated? Why is that a side effect? Yeah, basically that's here someone's already answering. Mutating the terminal is a side effect. Or the standard out. It's standard out. I think the proper term here is standard out. I think Wikipedia has also a nice definition of what is a side effect. Side effect, Wikipedia. I'm going to share my screen once I have it. I didn't check it out. Programming. Before I made this. Side effect. Side effect computer science. Now I'm going to share my screen and let us check the definition on Wikipedia. So here's the definition on Wikipedia. Side effect. And computer science and operation functional expression is said to have a side effect if it modifies some state outside its local environment. That is to say, it has an observable effect besides returning a value. And I guess if you check the standard out and you see change there, I guess that's pretty observable. Does it make sense?
Question is, why do I need pure functions anyway?
Well, a good question, which is difficult to answer. I would say you want pure functions to have a couple of benefits that you don't get if you don't have them. One of them is, for example, referential transparency, which is nice. And from my own experience, I would say you want pure functions because they are less error prone. State is the root of many, many bugs in computer science. Pure functions avoid mutating state, especially outside of the function itself, side effect. And that is, in my experience, the most common cause of a bug in programming, in software development. Well, that's not the best answer, I guess. There are better answers why you want to have pure functions. I think that's a great job to research. I think there are many good answers to that particular questions. I try to give the best answer that I could come up right now. Yeah, have a look into the chat. Many more people in this course have better answers than I have. Shall I continue with the next quiz question? So you see, element add event listener is like a JavaScript function which is adding an event listener somewhere in the DOM. And let's create a custom poll again. I'm going to use abbreviations now. Side effect, return value. So which one is violated here? It's sad that I cannot see the chat while waiting for the polling results. I'm going to publish, and this looks much better now. And again, it's side effect because it's obviously muting some state outside of the local environment. It's adding this event listener to this particular element. Think of that as mutating the function argument, for example. And regarding same return value for same input, I don't know. I would say probably no. I'm not quite sure about that, but side effect for sure. I hope that makes more sense now. I can see that you have the answers are better. I guess there's some learning going on. So I will ask the next question, what about math random? So you can check it out in your JavaScript console, go to a browser and into the console of random. And so it's creating a random, as far as I know, a random integer between 0 and 1. Custom poll. Side effect or return values different for different input. Different for same input, of course. So math random does not have any input. Like it just creates a random number. Or is it actually true? Maybe you can give it a seed. Okay, I'm talking about the function call that is not having any input. Just like returning a random number. Yes, correct. Of course. I mean, you will get another return value every time you call it. That's if you have a list which is empty, which are the arguments to the function call, and you get a different return value. That's pretty much the definition of not like having a different return value for a different input. And you cannot replace that. If you have that somewhere in your tree of function calls, then you must call every time you call the function, you will get a different result, right? That's a clear violation of referential transparency. I guess then the next question will be pretty easy as well. What about date now? So date now gives you a number, which is the current Unix time, as far as I know. Yuri, is that right? Your current Unix time, date now, correct? I think so.
Yeah. Also same with math random. Even if you give it a seed, I didn't Google it, I just used a node. But even if you give it a seed, it's always different.
Yes, and of course, I mean, time is something that is constantly constantly changing. So if I run the function now, I get a different result when I run the function 2 seconds later. And using date now, for example, in your components is a little bit more difficult. Let's say you want to create an animation. You have, I don't know, a couple of items, and you want to create an animation where one of them is always highlighted, just as an example. Then Vue.js is not really able to infer that it has to re-render the components, because date now is something that Vue.js has difficulties to, for example, create a computed property of. So you have to explicitly tell Vue.js, for example, you have to set up a timer, and if that timer is executed, then it's manually updating, for example, until dawn. Does it make sense? I will give you an example how that relates to programming, for example, in Vue.js. So every time you do something which is depending on date now, you usually have to do some more work than just leverage the existing framework capabilities like computed properties. I hope that makes sense as an example. Okay, I'm gonna have a look into the public chat, what people are writing. Can you get a pure function random generator? I mean, if you set the seed, if you have a random, true randomness in a computer is actually something really difficult to achieve. Because even a random output is based on deterministic input. And if you give it the same, if you give it the same seed, then also the result of the random function will always be the same. That is why I was a little bit confused when I was asking the question, because I was thinking, does math random also accept a seed, which I wasn't so sure about. So I was always thinking about math random without input. And then it's taking, I think, the system time as a seed. And that obviously also creates random output.
I think it also kind of depends on the implementation of the random method. Sometimes, for instance, here with Node, even if you give it the seed, it also, as you said, takes the time into account. But some random functions don't take anything additionally into account, I think.
Yeah.
And they just just use it as a, not just starting vector, but like the only starting point.
Yeah, my password generator, for example, takes my mouse movements as the seed for the random function. Like when I generate a random password, I can, if I want to, I can specify, take the seed from something outside of the computer, which in that case could be my movement of a mouse. Other seeds might be slight changes in the power, the voltage, right? I heard that this can also be taken as a seed for a random function. This is a difficult problem. It's a little bit off topic now, but I hope that gives you the bigger picture. All right, last quiz question. Await fetch URL method post. This is a method which is making an HTTP request. You can, if you write that into your browser and replace URL with a string, which is an actual URL, then you can issue an HTTP request, which is going from one your computer to another, a server in that case. So, which of the properties are violated? Again, side effect, return value, and when you HTTP request is done, you get a result which is the response of the server, right? So, but depending on if the server is listening, it might, for example, time out, or maybe the server is crashing, then you get an error, or if the server can handle the HTTP response, then you get some data back. All right, and you're all right. Actually, both properties are violated here. Obviously, it has a state effect. It has a side effect because I'm sending a message to another computer, right? Very much a side effect. And it depends on a lot of things what the return value might be. So if the server, for example, is, I don't know, currently under maintenance, then I get a different result when I run the same function again and the server is responding with HTTP 200, right? So both properties are violated here. Great, excellent. I can see that you understand like the definition of pure functions now, because first you had some difficulties and now I think everyone is on board. Excellent. Yes, both. All right, and there's another big topic in functional programming that is higher order functions, and you see that a lot in JavaScript. I want to introduce it very early in this course because I could see that many people from like last winter semester had difficulties with functions as specified as arguments, for example. And what are higher order functions? So higher order functions, as you can see, the definition is again on the left side. So you have a function which either takes other functions as an argument or it returns another function, right? So that's the definition of a higher order function. You see that all over the place in the JavaScript world. So in something to get used to especially when you're coming from C or Java. And on the right side, there's an example which we will cover a little bit later on this lecture when we just discuss authorization. This crude code here is doing a lot of magical things. Yeah. So I think this is the moment where I should probably give a quick live demo to show you higher order functions. So I have this code here already. And let's delete that for now and give a live demo of higher order functions. So what you already know is a normal function declaration, right? You can, for example, have a function declaration is called increment items, and you get a list as an argument, and then what you do is you return something, which is the list, and every item in the list incremented by 1. And if I then log out what's increment items of array 1, 2, 3, then I'll see 2, 3, 4. Very, very basic for now. So this is not a higher order function because this one is supposed to be an array. And this here is also another array, like the return value, right? So this line of code gets evaluated. It's becoming an array, and then I return that array. In order to make that a higher order function, I can simply return a function, right? So this is like an arrow function. It has no input arguments, and it returns this thing here. So what now happens is I have a function as a return value, and this is the way how JavaScript is outputting a function, right? A function is a piece, like a thing, and an object, if you want. Well, not a JavaScript object because that name is already taken, but it is something, all right? And that's just the way how JavaScript is typing it on the terminal when I console log it. And so this thing here, when JavaScript is evaluating that, it's not like returning the array, it's returning a function that when it's called will return the array. In order to, well, call that function, I simply have to go here and put parentheses. So parentheses, that's like the syntax of calling a function. If that here is returning a function, then I can call the function with parentheses, right? Does that make sense? Now I have the same thing again. Let's create a quick poll. Okay, I'm not gonna use double negation anymore. Are you with me? Yes or no? Does it make sense? Looks good. All right. Cool. All right. So another way of creating a higher order function is if I have functions as arguments. So if this function here is expecting a function, another function, right? And this is supposed to be a function, I can also put it, for example, here in the map. So the map is, by the way, the map is also a higher order function because it's expecting a function. So I'll put it here. And then I apply to list this function to every item on the list, all right? So the argument is here. This is the array, right? So this here corresponds with this parameter. And this is now missing. It would be undefined if I don't specify it. So now it's undefined. Okay, let's try it out. So what's happening? Undefined is not a function because like map is trying to apply undefined on every item, like on 1, 2, 3. It's basically saying something like undefined and then function call and then 1, right? If I put it here, then I already get like a crazy error. Okay, let's undo that. So I have to give it another function here. I can again write arrow functions and say item plus 1, and that's exactly what was there before. So instead of having this, what should happen with the list items here, I can, I don't know if I want to, I can like put that here, and then I can specify it when I use this function. All right. And then I have the same result again. You can see that here, right? So higher order functions. And this is a beautiful way of really like creating declarative APIs, and it's just, if once you like get a hang of it, it's amazing. And it's why I want to introduce it very early on in this lecture. And you see, once you have understood the syntax, you see it all over the place. All right. Back to the chat and the polls. Beautiful is very subjective. Well, wait until you get used to it, and then you don't want to do this imperative programming style anymore. And now, if you look on the slides, you can probably understand this crude code a little bit better. So you can see this is something that's coming from a package called GraphQL Shield. And you can see that here you have parentheses, so rule apparently a function, right? But what happens then? So this parentheses, you can see my pointer, right? Can you see my pointer? Can somebody say yes or no?
Yes.
Yes, nice. This parentheses belongs to that, right? So apparently rule, when you call it, is returning another function. You can tell that because it has a function call again here. It must be a function. And then you see parentheses there, which belong to this arrow function. It's only written on, like it has a line break to get it on the side. You can write it in one line. But this here is an arrow function, right? So rule is a function which, when called, returns a function which is accepting yet another function. And this function is then specifying a rule if, for example, a logged-in user is an admin, yes or no, and then the server can respond with, for example, unauthorized, or it can give you access on a particular resource. Yeah, so you can really write very small with like one-liners. You can put a lot of behavior into programming, but it's like you need to get used to it first in order to really understand, okay, what's going on here. Function inception, yes, that's it. It's very much like Inception. Right. Yes, didn't know you can destructure an object in place. That's correct. So this here is the third argument of a function. So you have parent, you have args. Parent and args is apparently never being used. So it's just there in order to get to the third argument. And the third argument is an object. And you can destructure the object in the function declaration, or the function signature already by writing that. So the object gets destructured and it has a key called user. It's the same thing as if you would write, I don't know, object there, and then you say object.user.role. Same thing. It's just a way of abbreviating it. Yeah. Destructuring arrays and objects in JavaScript is something you should check out. Yes, triple equal sign compares object and value and type. That's correct. If you, unfortunately, it's one of those ugly pieces of JavaScript. Then you write one, then number one equals as double equal sign the string containing the letter one. JavaScript will respond with true, and that's terrible. That's yeah. You should always write. You should get used to writing triple equal sign in JavaScript at the time and avoid it. That's one of the really nasty and ugly pieces of JavaScript. Okay. Yeah, and how can functional programming paradigms be useful? You saw that in the last homework. Every time you did something like this is a piece of code that's coming from someone who's used to Java or C. Right, you iterate an array by having this for syntax, and you have to specify a temporary integer, and then you go through you have a break condition, and you iterate, like you increment the counter here, the index, and then you do something with, then you reference the item in the array with with this index, and it's just terrible, right? There's a lot of implementation detail here. Furthermore, you have unnecessary state, right? So temporary array is a piece of state. Then you have this I, which is a piece of state, and it's all not necessary, right? You use map and you use filter and for each on arrays, or basically iterables in JavaScript, very, very often. I gave you, whenever I saw that in your homework submissions, I reviewed it as change that to the better functional programming methods, which like get rid of all those this unnecessary state. It might not be like terrible because it's probably not creating any bugs in this case, but if you can avoid state, you should do, because state is the root of a lot of problems and a lot of bugs in software development.
I have a question.
Yes?
But that's technically not state, because the array is local. So you're not mutating the state of the object that the function is residing in, you're just creating an empty array.
Yes, that's right. So this is local state, right? So it's not accessible from outside of the function. It's only accessible within this function in this case. Okay, let's think this doesn't exist here, right? I was thinking about your homework submissions where you were like doing those for loops, and it's just unnecessary. It's a minor thing, right? I agree with you that it's probably not a problem in this particular example, but it's just a problem in general. If you can avoid state, do it, right? That's the point here. Does that make sense?
Yep.
But you're right, temporary array is not accessible from outside of the function because the let is within the function block, and that means temporary array will not be reachable from.
Because when you say state, I think of side effects, and there's technically no side effect here.
Yes.
Okay.
This is, it doesn't have a side effect. It's just an example of, some state that's being, every time you have to reverse something, right? This is something you can avoid probably. And in this case, yes, it's local state, but still state. Yeah? All right. And the same thing could look like this, which is so much better, right? You see immediately, it's even better readable because you can focus on what's changing. You just increment something and you don't need all the extra code. So if you do apply functional programming paradigms, usually you end up with a lot less code. Okay, that's it regarding functional programming. We're halfway through the lecture, which is excellent because of one more topic. And these could be examples for excellent questions here. Any questions up to this point? Otherwise, I will proceed on with the next part of the lecture. There's someone writing in the chat. Explanations for previous questions. Yeah, all good? All right, seems so. Then I will go on with the next set of slides. Software testing. Software testing. This will be relevant for your next homework exercise. And it is one of the most important things. And it also applies, again, to the entire stack. No matter what you do, any kind of software, if you know how to do software testing, it applies to basically everything. It even is now part of DevOps because more and more deployment configurations are now part of software, and every software you can test. So again, software testing applies to pretty much the entire coding world, the coding universe, and it's something which you can universally apply to your entire future as a developer. And it has so many benefits. One of the common misconceptions when I talk to people about software testing is that most people think of software testing only as a tool to do regression testing. That is, You write a software test, and the software test ensures that you will not regress in software quality, meaning you introduce a bug. So when you introduce a bug, a software test will fail, and that will prevent you from shipping that bug into production. But actually, software testing has a lot of more benefits. One obvious thing is documentation, right? Written documentation quickly gets out of sync. If you have software tests and you explain what's going on in every software test, this is actually part of your documentation. And even better, it is executable documentation. So this documentation will not get out of sync when you change the production code, right? Otherwise, the test would fail. And then the developer who's changing the production code needs to change the software test, right? So documentation is a key benefit of software testing. If I check out an unknown piece of code or another repository or another software library, and I want to contribute, the first thing I do is to run the software test and see what's going on there to understand the behavior of the program. Again, there's another benefit. Software testing, you will benefit that your software gets more modularized. And by that, I mean, if you, for example, write a unit test for a particular part of your software, then you have to put this piece of software into an isolated environment. Means if this piece of software which is under test, has dependencies, think of a vue.js component which has properties, then you have to set up those dependencies in the test, right? You have to give those properties to the component. And then if you have a lot of dependencies, setting up those dependencies suddenly gets difficult and tedious. And that is the moment where you realize that my software is not really modular, right? Writing a test from the beginning helps to see dependencies in your code base. Because if you take a piece of software in an isolated environment like a software test, you immediately see the dependencies. And then you have the opportunity to reduce those dependencies just in order to better test the component. I tell other software developers, your software tests speak to you. The software tests are telling you where are the dependencies, right? The software tests are telling you how your software architecture should look like. Where do you need to make like boundaries, right? Which is like good software architecture. I don't do software architecture by writing like painting diagrams or do like models. I do software architecture by writing software tests, because the software test will eventually tell me how the different parts of the software should be structured. So 7 more messages in the chat. What are people saying? You're only testing if you write perfect code. You really want to make me upset, I guess. No one writes perfect code. Yeah, I know, you were just kidding. I know. I get the joke. Yeah, actually, it's funny because a lot of managers think the same. They don't get the joke, right? So a lot of managers who are not in software testing, software development, they really think that why you need software tests if you just have good developers, and then it's not so funny anymore. All right, the 2 other benefits, big benefits of software testing is that you can refactor with confidence. From my experience, when I was working in a software company before, a lot of software developers feel afraid to touch the existing code base if there are no tests in place, because they are afraid of breaking something. Who tells you that you didn't break something if no software test is telling you you broke something, right? If there are software tests who give you some confidence, some security, then your developers are much more willing to do refactoring, right? If you have no software tests, this has a human effect on your, like a psychological effect on software developers, because they're just afraid, and then no one is like refactoring existing code, and you pile up technical debt. And the last advantage of software testing is that you prevent over-engineering. With software tests, you specify the desired and required behavior of your software and nothing more. Over-engineering is a common anti-pattern that a lot of developers have when they come out of uni. At university, you get taught the beautiful part of algorithms, for example, and the abstraction and like one silver bullet for 10,000s of problems. And then you have the misconception that when you go into the reality and you start to develop software in for real, that you can have one beautiful piece of implementation which is solving everything, like every problem which is about to come. And you start to over-engineer your code. You put in a lot of abstraction because you're anticipating changes and everything. If you do software testing and you just implement software that is fulfilling what the test is asking for, this is also a nice way of like preventing over-engineering, because like in 99% of all cases, you're about to solve problems which will never happen, right? Many developers want to solve problems that don't exist. And that makes your code unreadable, unmaintainable. The cost of over-engineering is unmaintainability. And that's something that you can avoid also with software testing. This diagram should give you a great overview about the good arguments for software testing. Hire an internship and get test trophy. Yeah. Why don't we test the test? That's actually a good question. And what the technique to test a test is called mutant testing, and we get to that later. Right. Yeah, and that is the definition. A software test is a software that tests your software. This also, again, highlights that software test is part of software development. It is not something external. It is part of software development, and you're supposed to like use resources on it, your working time. So if you have a boss, then it's okay to spend 70% of your working time on writing software tests. It's nothing unusual. I would say I use about 50 or 70% of my time. If I implement a feature, I spend on writing software tests, and I use 30% on writing the actual production code. That's nothing unusual here. So it's part of software development, and it's good that you use so much time on it. Okay, and again, this is relevant for the final exam. It's here again another definition. We are doing a lot of theory now. When we talk about false positive and false negative, it's important to define what do we mean by positive or negative. So a positive is if a test fails. Okay, think of a medical test, HIV test, coronavirus test. We talk about positive if the test is telling you this person is infected, right? Therefore, a false positive is the test says the person is infected, whereas in reality the person is not infected. That's a false positive. In contrast to the test says the person is not infected, but in fact the person is, right? Transferring that to software development, so software testing, this means the software test fails, meaning my test is saying I'm infected, and false positive would mean the test is failing, but the software is all right. False negative is we have a bug in your code, you have a bug in your application, unexpected behavior, but there's no test which is failing. The test is not failing. Does that make sense? That's quite important to understand the definition here. Are you cool with that definition? Cool. Kinda. Yeah, it's just important that we define it. You can also define it the other way around, but it starts to get confusing. Like some people like to define it the other way around because they think positive means the test is not failing or something. I really like to think of to have this metaphor of having software tests which is similar to a medical test. And because people are saying positive test and they mean test is saying you're infected, I just use that definition. You don't have to use that definition, but I will probably ask all questions in the homework and later on the final exam, assuming this definition. Does a false positive mean the test is not complete or faulty? A false positive means, for example, well, false positive means the test is not doing its job, right? The test should, you can just write a test which is titled, I don't know, think of the example code, increment items. And in the test implementation, you just say fail or throw new error. So the test is always failing. Then the test is not doing what it's supposed to do, given the description that it's testing that if you give it an array, you get an array back with incremented items, right? That would be an example of a false positive. So yeah, it's actually a good question here. False positive, and maybe I should define it a little bit more. You have usually a description of a test, what the test is supposed to do. And the test implementation is obviously not doing that.
So that's why we test the tests. So that's why we test the tests.
Yeah, that's called mutant testing, and we get to that later. All right, I'll continue on then. It's also a nice diagram. The so-called testing pyramid. And we have different types of tests. Let's call them different sizes of tests or different calibers of tests, because we can decide how big is the subject that is under test. Like, what's the subject under test? Is it like a method, or is it a Vue.js component, for example? Or are we testing the entire application, including the entire software stack? In order to distinguish those three types, in software development, we have a history of like we have a vocabulary for those things. And usually people are talking about unit testing, integration testing, end-to-end testing, and sometimes people are also talking about manual testing. So manual testing obviously is not automated testing. When I talk about software testing, I usually refer to software, which is testing your software. So that's automated testing. Manual testing is basically just have a human in front of your program, and this human person is then testing your code. Most of the time, this doesn't play any, like, this has no really importance to us, because we are learning automated software testing here. So end-to-end testing is like the biggest caliber, the biggest size of a test you have, because it refers to, if you think of a web application as this software stack, is testing the entire software stack. It's like, that's like one end to another. Like end-to-end testing refers to the end of the both ends of the software stack. So you have, for example, in case of a web application, you have your browser, and the test is basically just automating, interacting with the browser, right? And then the browser sends and like is interacting with the front end. And the front end might interact with the backend, send HTTP calls to the backend, for example. And the backend in turn is like accessing the database and so on. And then it all goes up the software stack and returning in a result, which will lead to another website, which you can then see, or which the software test can see. And then the software test can say, is that the result that I'm expecting to see or not? And then fail or pass. That is an end-to-end test. It's like the biggest test that we can think of. On the lower end of the pyramid, we have the unit test, which is like the smallest unit of test. A unit test, for example, could be you testing just a function. If you have, for example, a pure function, you just put something into the function and then you have a result. And in the test, you're executing that function, just comparing it with the result value, if that's what is expected for that particular piece of input. And something in between that is the integration test. Integration, because you're usually integrating more than just one unit of code in one test, right? For example, when you're testing your component test, that is, I would say, it depends. It's a little bit blurry here, the lines. At least when you have a component that is importing another component, for example, then you have multiple components which you're all testing together, right? That would be a proper integration test. All good so far regarding that. Cool. I guess you have heard about it in other lectures, the testing pyramid. It's quite common, a little bit outdated, the idea, but yeah, I guess a lot of people have seen that before. Now, considering we have a web app and maybe a backend, you can also have this line here where you can say, okay, one part of the pyramid is testing the front end only. That's your Vue.js application. If you have later on a backend application, you can also unit test that. And these are independent of each other. Once you do end-to-end testing, where you use a real browser, where you test the entire stack, obviously with one test, you're hitting both the front end and the backend. And that's why you don't have the separation here. Another property which you can see on the testing pyramid is on the left, on the right side. So when you go down the testing pyramid, the tests are usually getting quicker in execution. And when you go up the pyramid, your tests are giving you more confidence about that your program is behaving as expected. And why is that? If your types of tests are getting smaller because less and less parts of your code base is under test, then obviously the execution time of one test case is getting smaller. So the tests are quicker, they are being executed much faster, which is nice because if you have a lot of test cases in your code base, every test case is adding some seconds to your build pipeline. So it has a cost. Adding a software test has a cost as well because you have a longer delay when as a feedback from the build server. So you write some code and then you push your code. The build server is testing the entire test suite. It takes some time and you get feedback. And this delay gets longer for every test case, right? It is advisable to try to write tests that are quick in execution because you don't want to have a long delay until you know, okay, my build server has passed, I can merge this code. To give you an example, I was working in a company where every run of a build server would take an hour. That's a lot, right? So the build server will test the entire code base and this take 1 hour. So think of every commit taking 1 hour before you get a result from the build server, everything is working fine. That's a lot. It can slow down development. So you should write a lot of unit tests because of that. A drawback of unit tests is because only so little part of a code is under test, you don't get as much confidence. If you're testing more code and you have one bug in one of the places that you're testing, then it's likely that your entire test will fail, right? If you have just a few parts of your code base which you're testing, then you have a bug outside of this area, the test will still pass, right? So a small unit tests give you not as much confidence as do end-to-end tests, for example. So you can see the difference here, and you can see the disadvantages and advantages of both, like calibers. I call them calibers. I think of like having a software test, like having a piece of weapon, and I'm shooting on my code, and either I can use the bazooka, which is like the end-to-end test, or maybe I have a small knife which I stab into the code somewhere. This is my thinking of it. And yeah, so the idea is to get best of both worlds, is that you have a lot of unit tests. So you should write a lot of unit tests. You should write some integration tests, and you should write few end-to-end tests because of that. So that would mean you got still an acceptable execution time and acceptable delay in feedback from your build server, but you still have a lot of confidence when you have a few of end-to-end tests which are testing the entire application. Yes, a lot of talking. Are you still with me? Again, a lot of people are saying yes. I assume that you've seen that in a lecture before. You can write to me in the chat and tell me if you are familiar with the testing pyramid. Cool. All right, time for a live demo, I guess. One slide more before we go into the live demo. So what you're supposed to do in the homework is you're supposed to test your components. And you're supposed to do that with Jest, which is a JavaScript test runner, and vue-test-utils, which is a software library in order to test components, Vue.js components. So this diagram shows you that you can use Jest, the test runner, for not only component testing, but also when you later on write a backend, you will use Jest again, right? But vue-test-utils is a software library which is which allows you to test your components, and you can basically incorporate vue-test-utils in your Jest test suite, or you can run software tests that are importing vue-test-utils as a library. People are writing into the chat. Never seen before. Interesting. Never seen the pyramid, but knew the facts. Well, it's very, very common. I didn't came up with that myself. All right. So having that said, let's dive into the live demo. So I'm closing the chat, sharing the screen again, and go to this here and clear that and remove example code. And I will set up, for demonstration purposes, I'm going to set up Vue CLI. You can follow these steps when you do the homework. So I'm just creating a new project with this command. Why not? Create hello world. Will take a little bit of time. Yeah, install this, which will get me set up with some Vue.js components. And if I go to vue-test-utils, the documentation tells me I can also, well, the default and the most easy installation is to use Jest, which I introduced to you. So that's the tutorial that you should follow. And there's also a nice plugin called Vue CLI plugin unit Jest, which I can install, which is doing like the setup of installing Jest into my project. And then all I need to do is basically to install the library and tell Jest to transform those single file components. Let's do that. So in the meantime, my hello world folder has been created with a couple of node modules, and there's already this hello world component. And I can now go into that and run vue add unit jest, which is creating more code, which is adding more code. Yeah, there are uncommitted changes. That's all right. So I get like a basic setup for Jest. Waiting until the code gets generated. Yeah. And now I have another script available, which is saying test unit. So for them, apparently, they consider component tests as unit tests. Well, I would say it's questionable, but anyways, let's run test. Oh no, actually, We didn't talk about, Jest doesn't know that we are testing components. So it's actually quite okay to call Jest tests unit tests. Okay, forget what I was just saying. And there we go. We have already an example spec. No, hello world. In folder test, which is interesting because I didn't install the library for vue-test-utils. Am I in the right folder? So maybe I was having old node modules already, because actually you still need to install those with this command. Like I'm using yarn, so I'm calling yarn, yarn install. No, yarn add, npm install and yarn add for development. And I have to tell Jest to transform maybe this is not even necessary. Sometimes I'm a little bit confused with the generated code. Usually you have to tell, because Jest is a test runner, which doesn't know about Webpack and so on, you have to tell Jest how it should treat files which have the ending .vue, which is a single file component. And you have to tell it how to transform this into or transpile this into HTML and JavaScript. And you do that by specifying that in package.json. All right, but same thing, test unit. There we go. So let's have a look into the example spec in order to show you that you don't have to really use vue-test-utils in order to write software tests. Let's write a demo spec. By the way, spec is short for specification. It is emphasizing that your tests are your specification, aka documentation of your code. So this is now being executed with Jest, and Jest gives you access to a so-called list of globals. A global is a globally accessible identifier, so you don't have to import this. Globals in JavaScript is, for example, console, and in the browser environment you also have window and document. And if you just have another identifier which JavaScript doesn't understand, then you would usually get an error. Maybe write the file first. All right, cool. Anyways, but if I, for example, run this, what's going on? Test unit. Where am I? Save. Hello world. Tests unit demo. It's not there. Okay. Close all terminals. What's going on? Strange. Okay, let's close this as well. Hello world. Tests. Okay. Spec.js. Okay, random identifier. And if I try to run this, for example, with Node, then I get an error because it doesn't know what's that. But Jest comes with a couple of globals. For example, describe. And with describe, I can, for example, test let's say I have a function called increment items, which I had before, list. And it's returning list map item. Let's just do that for now. So that's my subject in the test. So I'm going to write describe increment items. It's usually how I start to write a test. I'm describing what do I want to test, and here you can see we have a higher order function again. So describe is something that's coming from Jest. It's a so-called global. So Jest knows this describe already. And with it, I'm describing a block of tests. And my outermost block is I want to test increment items. It's usually great to specify what you want to test. If it's a component, you would give it your component name, right? Now I want to test this JavaScript function. And here you can see that there's another callback, right? Here's a function. You pass a function into a function call. So describe is actually a function, right? So you have a string, which is a description, and you have this arrow function here, which is being executed later on. So this is how I give control to the testing framework. Okay, and then there's another global called it, and that's my test case. So increment items, you can read it like that. It adds +1 to every item, to every list item. What about that? And again, here is my function, which I pass in. And I can, for example, then say expect another global increment items. Now this refers to this function. And then you give it an array, right? And then say to equal 1, 2, 3, 4, that. This would be a test case. So here's my subject under test, increment items. I give it some input, and then I just basically testing the output. It doesn't have anything to do with Vue.js components. And still, this is just jest, right? So this is the purpose of this demonstration is to show you that jest is something different to vue-test-utils. Jest is actually a framework developed by Facebook, originally for React.js, but now it's like a JavaScript test runner which you can use to basically test anything in JavaScript. And here you can see that it's now rejected. Another nice thing is if you specify test unit verbose, you see the test descriptions. You can see the test descriptions here. So increment items, and then my description from the test case. And this indicates if the test was failing or not. Here's another like auto-generated test. All right. Now, if I just fix the implementation, test is passing, right? Awesome. So this is also a showcase how to do test-driven development. I write the test first, and then I write the implementation. You call it, if you test drive a particular feature, right? You write the test first, and then you implement the feature. And this is a nice example. If you do that, you also immediately see if it's turning from red to green after you implement it, then you can be sure that your test is doing something because it was red, then you added the production code, and then it turned green, right? So you can be pretty much sure that both your test case implementation as well as your production implementation is working as expected. What's the time? It's 20 past. Are you still with me? Yuri, shall I continue on, or shall we use the remaining time for questions?
I mean, we can try to answer the questions first. The one question is whether we can expect multiple, or whether we can use expect multiple times.
Yeah.
Whether you have to use.
There are some best practices. And one of those best practices says you should have one expectation per test case. But there are examples where you can have multiple expectations. It makes sense. One of those examples is actually on our slides. This. A way of sanity checking your tests is that you have a setup of your test case. You have usually this pattern, arrange, act, assert. Sorry, this one here, arrange, act, assert. So you bring your system into a particular state, then you do something, your action, you act, and then you have your expectation, the assertion. That's like a pattern that is common you see that in all software tests. You bring the system into the desired state, then you do something, and then you expect something. That's arrange, add, assert. It's a pattern you should always follow. There are examples where you can have multiple expectations to sanity check your test case, sanity check your arrange, your setup, and also sanity checking that your action is changing a particular result. So if you have a component which has list items of length 3, and then you click a button saying delete, then you can say now it has 2 items. This additional expectation here is ensuring that there have been 3 items in the list before, right? One way of having a failure here is that you, for some reason, messed up your test implementation. You have 2 items already. Then you click a button which does nothing. And yes, of course, your list items are have the length 2, right? But nothing has changed, and you wouldn't see that. So this is a way of like sanity checking your test cases. In other languages like Ruby, the testing framework actually has a particular syntax for that. You can, for example, say expect block, like in the block you would have the action, to change. And what the test framework is actually doing is checking first the assertion, then executing the block, and then checking the assertion again. Yeah, Jest doesn't have that yet. Maybe it will have it in the future, and so you have to do that yourself. Does that make sense? Does that answer the question? Yeah. Okay, I'm stopping with content for now. I think it was a lot. People are already complaining it was much too fast. You can always, I will make sure that this video is going to be online sooner than last one. And you can always rewatch the lecture. Yeah, that's actually a special case. But usually for 90% of all cases, you have a range act and 1 assertion. So best practice is to have 1 expectation per test case. More questions? Feel free to unmute yourself or write it into the chat. I talked a lot. I'm always getting nervous when I'm talking so much and I don't get so much feedback. Feel free to ask questions. I think it's good for today regarding content. Well, no questions in the chat. No one is unmuting his or herself. It's now 27 past 3. Yuri, is there anything unclear?
I don't think so. So somebody asked whether we can upload the PDF immediately, so it can be used during the exercise, and this is what I just did. So you can find it in the in the Moodle.
Yeah, I can also. I think there's also a setting here where we can say presentation download is allowed. Yes, confirm. You can even download it from within this big blue button meeting room now. Thank you. Yeah, well, I'm now still here for you to give you more, clarify things. You just have to talk to me. Well, but unless there are questions, I would say we see each other in 15 minutes from now for the seminar, right?
Right. Today is mainly setup of the whole test setup and jest and everything regarding that. And there are something you didn't mention, but I think people will see in the exercise, and maybe you will also explain that stuff next week.
Yes, storybook. It's part of next lecture. It's about component development. So the moral message or the idea behind homework number 2 is that you get a feeling how your components are things that can be tested, played around with and styled, isolated from each other, right? And one way is writing a software test for the component. That already will lead to a loose coupling, because you're forced, in a way, you're forced to get rid of the dependencies. Another way is you use Storybook, which is like an interactive playground where you can see, where you can render the component on a blank website, and then you can, for example, change properties, and you see the properties changing the component in real time. It's being used for front-end development a lot in order to create really highly reusable, high-quality components. And that's another way of also getting a better feeling how the components should be, like how the interfaces to the components should be, and yeah, how components can be reused in different environments. Could you clarify the requirement that somebody has to review our PR who's not a member of your team, but another team member is fine? So you're talking about the receiving side. The requirement is on the reviewer side here. So I want you to interconnect, share knowledge with each other. And I also want to give you the feeling how it's like when you give someone a review, right? You're currently just receiving reviews from us, the mentors, but actually code reviews works in both ways. We, the mentors, know someone, like learn more things from your assignments, and you get feedback on something. So to give you that feeling, that's why this task is in this homework, right? So you also should review another code and learn something from others, and also give your feedback by doing line-by-line suggestions, right? And then you learn this. First of all, you learn the workflow of giving code reviews within a team. And someone's writing a member from another team. Yes. So you give a review to a team member or a team which is not your own team, right? A review to a repository of another team, to a pull request within a repository, to basically an assign, like it's a submission, or actually just a pull request. You can review pull requests which you haven't been explicitly asked for to review. You can always review. I think members within the GitHub organization systems development and frameworks can always review pull requests from other teams. If not, tell us, and we'll have a look and we'll set up the permissions, right? So if because of permissions it's not possible, please tell us. The idea is you should always be able to read and review other teams' pull requests. Let's find one student who we all ask. Yeah, but once this team is receiving the first review, implementing the changes, it's getting better and better and better, and there's not much left to review then, right? So it's best if you somehow look around, find a repository where you can see things to improve. The point here is you should get, you should understand the workflow, you should learn the workflow, you should feel, I'm learning something from looking at other people's code. And you should also use the approve and request changes button, because request changes obviously means this pull request has things to improve. And if you approved something, then you give your own certificate. This is now approved, no approval. And I'm taking responsibility in some way, right? If you're working in a team and you approve someone's code and later on this pull request gets shipped, then both of you are kind of responsible for the code. Well, at least you're always responsible for the code, but it's also giving you another connection, a psychological effect. Does that make sense? And that's why it's specifically required to use approve or request changes. More questions? The review is obligatory. it's showing up in the, it should show up in the obligatory objective. So it has a star, not a rocket. The other thing is about the pair programming.
Yeah, exactly. There are two different ones. The last star, the last point you get is review a pull request of another team. So what you guys said, let's just find the one person who's reviewing, who's doing all the reviews is not working, because the task is not to get a review, but to do a review, in your team. So this is up as a task, and then optional is to take somebody and do to record a online pair programming with that. This is where your quotation is from.
Yeah, exactly. So doing online pair programming is basically using the knowledge that we got from last lecture. Last lecture we introduced online open source communities. I want to encourage you to try it out. Like maybe you can find people online who are interested in test-driven development, right? Test-driven development is something that a lot of people on the internet are interested in, and they love people who are in this course and are doing homework on this particular topic, and you can share that knowledge with them. You don't have to if you don't want to, up to your choice, but I'm strongly encouraging you to do so. It's a nice experience.
Okay, then maybe we go to a small break and see each other in 15 minutes again.
Exactly. So now I'm clicking the stop recording button.